The final day of Microsoft Ignite, the brave souls that are still here early in the morning. How many of you went to the party last night? Everybody almost, yeah? Awesome. Everyone had a good time. Who was up the latest? I was up till probably 1 a.m. or something. You know those shuttles take forever to get home. Same, yeah. 2 a.m.? Ooh, you beat me there. All right, so hopefully people didn't fill up too much on butterbeer from Harry Potter land or other things like that, right? But we're here, we're awake, we're present. This is going to be exciting. My name is Kyle Weller. I'm a PM on the Azure Databricks team. And today we're going to talk about the applications of time travel with Azure Databricks Delta Lake. So just so I can gauge the audience real quick, who here has heard of Azure Databricks? Hopefully most hands. Yeah, good. And how many of you have used Azure Databricks? All right. Shout out a couple things. What are your favorite things about Azure Databricks so far? As you've been using? Fast. All right, what else? Blazing fast. I love it. A good fan over there. What is that? Managed. Nice. I love it. What else? Favorite things about Azure Databricks? Secure. Nice. All right, you guys got the bases covered. Good. We got some good fans. Now, how many of you have used Delta Lake? Yeah, a little bit fewer hands. Good. Okay, so we'll talk about Delta. We'll talk about what it means, why it's important, why you should care. And then we'll kind of go into an angle of time travel. I actually have this listed on the agenda right here. Yeah, so we'll do a little 101. You know, this is being recorded. I want to make sure everyone can get the 101 as well. Talk about the architecture patterns. Make sure you understand where Azure Databricks fits in. Then we'll hit the Delta and the applications of time travel. We'll do a sweet demo, and we'll go through. So, of course, feel free to poke some kind of questions if it's real burning. Otherwise, we'll have Q&A at the end, and I'm going to stick around for a long time, too, if you guys want to have deeper dive discussions and conversations there. So, to kick us off, as you all know, data is the lifeblood and catalyst of almost every industry around the world today. The amount of data being collected is on a rocket ship growth trajectory around the world. So as companies and individuals like yourselves seek to capitalize on this revolution, I know that you're faced with several challenges today. These include complexity of solutions. With so many options in the marketplace, with your workforce talent developing across so many different technologies out there, there's complexity in the solutions that you're trying to build and develop. And while your company may have massive amounts of data captured, this data is usually not accessible. This data is usually not democratized or even reliable. And so with unprecedented growth and complex workload demands, many companies find it hard to scale with their workloads efficiently. How many of you, is there anything on the screen that rings true for you? Anyone feel like their data lakes are more like data swamps? Anyone feel that? A couple chuckles, good. So we know that people aren't satisfied with the solutions that they have today, and that's why Azure Databricks is one of the fastest growing data analytics platforms on Azure today. Azure Databricks is a fast, easy, collaborative Apache Spark analytics platform aimed at helping you increase your developer productivity, automatically scale with your most demanding workloads, and achieve enterprise-grade security that's easy to use. I think I heard almost all of those comments come out right at the beginning. Now, our customers have three common objectives. They want to extend to untapped data sources. They want to get deeper insights through machine learning and AI. Our customers want to get these insights faster. They need to get them in real time, near real time, and they need to turn these projects around much quicker. So here I'll just show you a quick example of some use cases and show you the variety of how this applies to almost every industry that's out there. I won't read through all of these applications, but just imagine these scenarios and throw out, if you guys want to yell out if something rings true to you. We have customers in the retail space, financial, oil and gas, security, healthcare, advertising, media entertainment, sky's the limit. These are a couple examples of what we have customers doing today in these various industries. So how does Azure Databricks fit in? How do you architect an entire data engineering pipeline on Azure with Azure Databricks in the mix? So of course, you're going to start with a wide variety of data sources. Data that might be structured, data that might be unstructured, data coming from various different applications. You might have some data coming in real time. So here, you start off with ingesting this data, bringing it into a common data lake, centralizing this data to make it accessible and usable by your company and secure. Once you have it in this data lake storage or equivalent on Azure, you can use Azure Databricks to process this data, to clean this data, transform this data, enrich this data, apply machine learning, train machine learning models, use Azure Machine Learning and ML Flow together to manage the whole ML lifecycle. Deploy these models that you train out to AKS, Azure Kubernetes Service, or otherwise. Maybe you need to load this data into operational databases, Cosmos DB, Azure SQL DB. Maybe you need some more advanced data warehousing solutions or serving layers for BI scenarios. And you can leverage Azure SQL Data Warehouse or our next-gen data warehouse technology, Azure Synapse, that was announced this week. And then you've got Power BI, the amazing visualization tool, market leader of Power BI, to help you visualize and do BI solutions on this data as well. So that's how Azure Databricks fits in with the rest of the ecosystem. So Azure Databricks, everyone had already heard of Databricks. Most of you had already used Databricks. So I think now we can get into Delta and what is Delta Lake, because I saw fewer hands of those that had used Delta before. So we talked about briefly how Azure Databricks can help to solve some of these basic complexities. Some are around complex data, diverse data formats. Also in the streaming context, data can be coming late or out of order. And with structured streaming on Apache Spark with Azure Databricks, that's pretty easy to solve. And of course, data being dirty, you can clean it up fairly well with Azure Databricks. You have complex workloads, combining streaming and batch data together. With unified APIs for streaming and batch, this is a super powerful tool to help you take, you can even upgrade from traditional batch, daily kind of jobs, very easily start upgrading these to near real-time streams. Or maybe more likely you go to like hourly or whatever it is. You can set different kind of intervals and different ways to manage these streaming workloads. Of course, you're dealing with a wide variety of complex systems. Azure Databricks, being a first-party service on Azure, is deeply integrated with the entire Azure portfolio. AAD authentication built in out of the box. You can have pass-through with that authentication down to your storage layers. We have engineered together with SQL Data Warehouse and Synapse highly optimized connectors, high-performant connectors, so that you can work between all the various Azure data services and get smooth integrations. So with some of these complexities solved, there's other challenges that are still out there, inherent to Spark or otherwise. So some of these challenges include concurrency. How do you solve for multiple readers and writers on the same data in the same data lake, ensuring atomic transactions, et cetera? The small files problem. Probably each of you have encountered and faced this already today. A lot of you had used Databricks before, and so you've probably been in the big data space for a while. So I'm sure you've faced the small files problem that you have to deal with some performance degradation there, or start cleaning up or compacting these files, and it can be a complex process, an engineering-intensive process to solve. Now, of course, the day and age that we live in today, GDPR is of extreme importance, and you need to process delete requests or other kind of upserts. And always, it happens to everyone. Data is going to be messy. You're going to have to roll back. You're going to have to reprocess. You're going to have to update this data in some way. So those are some other challenges that are still there, even with Spark or just Databricks on its own. And that's where Delta Lake comes into the picture. So Azure Databricks Delta Lake The secret sauce is, I'll walk down over here. The secret sauce is right over here in this corner. And we're talking about, we keep versions of these Parquet files. Parquet is a file format. Just like JSON, CSV, Avro, Parquet is another file format. So we keep versions of these files, build a transaction log, and add some additional indexes and stats for performance improvements. And some of the things we're able to accomplish are listed up on the top of that slide there. And I'll walk through some of these. One of them is ACID transactional guarantees. We talked about concurrency. If you have a data lake and you are cleaning, transforming, you're building this data lake, all these files, you want to have many people in your organization be able to access and read and or write at the same time to these files. And if you have a transaction log, now a reader comes to the transaction log and says, what is the latest commit? Start reading it. Someone could be writing at the same time to that same file in your data lake. So this is old news for a lot of other technologies, but this is at your data lake scale. Terabyte, petabyte scale, ACID transactional guarantees, high performance. So we talked about the version Parquet files in the transaction log. There's also additional commands that are available with Delta Lake, like merge, delete, update, insert. You have small file compaction. There's a command that you can run in the background on a separate cluster, is the recommended way to go, called optimize. And with optimize, it goes and it compacts all of those small files down into larger files. And it does this all for you. You just write a one-liner command. You don't have to spend weeks of engineering effort trying to build this cleanup process. Vacuum is another command that helps you delete the history altogether, because this is keeping history around. Let's skip to the bottom one. Time travel. So because you have a transaction log and version files, what you can do is write a query that says, select my data from this table as of a particular timestamp, and just recreate that data in a previous version. So vacuum, backup to vacuum is the command that lets you delete this history altogether and control how much history you keep around. So another thing here is this Z-order partitioning. So everyone's already familiar with traditional partitioning, and this is going to create subdirectories and folders of your data, and you need to partition on low cardinality columns, right? And you might get performance and efficiency out of partitioning one, maybe two low cardinality columns. With Z-order, you actually Z-order by high cardinality columns, and now you've created like a multi-dimensional partitioning scheme where in each file, they order by the Z-order that you choose. And so now when a read operation comes, and imagine you Z-ordered by timestamp or some ID or something like that. And so now you've enabled this concept of data skipping, where because there's indexes and stats built around each of these files, the query processor can skip all the files that don't contain the range of the data that you're trying to access. And so we have real customers out there today achieving 100x performance benefits by leveraging file compaction, Z-ordering, some of these other best practices using Delta Lake on Azure Databricks. So now Delta Lake, some of these concepts, I put a lot of stuff up on the screen, a lot of features, a lot of functionality. It may seem complex or hard to get started. It's very easy to use. Out of the box, you used to be saying .format Parquet, .format CSV, .format JSON, whatever it was. Now you say .format Delta, and it's working right away. Some people at the booth during this week, they asked me, so what's the cost? What's the cost of this? It's built into the product with Azure Databricks. No extra cost for this. So to help you see where it fits in, because also another common question that I hear is, maybe because of the name of this feature, Delta Lake. Like Delta Lake, so is it different storage? How does it really fit in? So hopefully this slide makes it a little bit more clear. And I had a transition. I don't know where my transition went. But so here, Delta Lake, you can think of as kind of like it's a new storage format technology. And so Azure Databricks is always a separation of compute and storage. And so you bring your own storage, like Azure Data Lake storage, blob storage, whatever you want to bring, and then you can transform that data from its raw format to this Delta format, and be using Delta for high performance, reliability. You know, the tagline that I had up on the previous slide, reliable data lakes at scale on Azure. Bringing reliability to your data lakes is another tagline that you hear. One thing that I skipped over on this slide is talking about schema enforcement. Schema enforcement, it's a schema enforcement on write. And so now if you're trying to change columns or insert data of the wrong type, the schema enforcement will help you be safe, and it will block those writes from happening. Of course, you have a way to tune and say, hey, let's always block and enforce the schema really rigid. Or you can say, actually, let's decide to merge schemas. Or you can say, oh, it's OK, let's leave it really flexible and always overwrite the schema. You have a couple options at your hand. But now you have this tool with schema enforcement that helps you enforce some reliability into your data lakes. So let's do a double click. You know, this diagram is really high level. Let's do one more click down. It's still going to be a little high level, but we'll get deep in the weeds with the demo. I'll show you real hands-on this stuff in action. But here, so you're starting with step number one. You're loading all your data. You're getting it into your data lake storage. This is that dotted line, gray box on the bottom, data lake storage. You're getting it in as is in its raw format. Then you're going to use Azure Databricks. You can combine streaming and batch together. With Delta Lake, you can even avoid Lambda architectures and have much more efficient processes and pipelines that way. You can start writing this data down in this Delta format. Now, if you do this at the beginning without introducing any additional business logic or without cleaning or doing extra operations, you've now enabled, if someone needs to go back to the raw data as it was, like unfiltered, untouched, and oftentimes you'll have engineers that need to do so, you now have that raw format, that data raw as is in this Delta format, that you've now increased the performance by 100x if you tuned it the right way, and you have made it reliable as well. And so you have this raw data in that format. Now, maybe you start joining multiple data sets together, you start enriching it, transforming it, and adding maybe some business logic or some aggregates. Use Azure Machine Learning, MLflow together. You can start training and building ML models. You can score and add inferences to this data. You know, this concept of bronze, silver, gold is just a hypothetical concept to help you see that these are like multi-stage pipelines. That at each of these stages, you're democratizing this data at each of these stages because of the asset transactional guarantees, the concurrency you've enabled, the reliability that you've brought into the equation, the higher performance and access of reads of this data. This is all available to you in your centralized storage, Azure Data Lake storage. Now, then you can go into serving layers. We already talked about these like Cosmos DB, SQL DW, Azure Synapse, whatever it might be, to help you achieve the end game that you're looking for with Delta and Azure Databricks. So hopefully that is a little bit better of a double click on Delta and what it is, what it really means, why you should care. So now let's talk more about time travel. You know, that was the title of the presentation. So let's get in and talk a little bit more about that angle. So time travel, we mentioned that you can write queries that look like this. You say select your data from your table. You can say timestamp as of a specific day. You can say timestamp as of and do like a current day -1. You can also do these by access by version numbers. I'll show you how you can look at the table audit history, and then you can pick version numbers or things like that. And so some of the applications that we'll walk through include being able to get audit history of this data, data reproducibility, data pipeline debugging, immediate rollback capabilities. So we'll go through each of these. But just really quick before we dive into those, let's make sure we understand how time travel really works. So on this screen, I took these screenshots. There's an excellent blog post. If you search Azure Databricks transaction log or something like that, it'll probably be the top hit. There's an excellent blog post by Databricks that goes in through the details of what the transaction log is, what it really means, what's happening with each operation. So I recommend you go read. Here we'll talk just briefly the transaction log. When you do a write, and I delivered a hands-on lab session on Wednesday, and so we went through and we looked at this all together. If you look in the file system at when you write those Delta-like files, this is what you'll see over on the left-hand side. You'll see a transaction log. It's this _delta_log, and each of those JSON files are individual commits. And then your data will be they'll be in Parquet file format. You'll see all your data there. If you decide to partition, you'll have partition directories. And when new transactions come, so let's say the very first transaction, you just added 2 Parquet files, just so that you created this table initially. And then let's say you did some operation and those data files were no longer relevant, but you added some new Parquet file. It will, in this transaction log, take notice that we no longer need version Parquet 1.Parquet or 2.Parquet, and 3.Parquet is what you need to reference if you're looking at the commit of 01.json on that commit. So this is under the hood just to make sure that we've got this understanding on how time travel works. So here on the screen, we're going to talk about how you can audit data changes. You can write a command that says, is it large enough on the screen? I hope it says describe history of my table. And if you write describe history of my table, you get this peek here. You can see what user IDs, what timestamps a commit was taken, what the operation was, some of the parameters of that operation, what notebook it came from, what cluster or job that it ran on. So you get a lot of kind of audit information, this audit trail. You might want to use this for compliance regulations, security, even just debugging. There's a lot of value and use to having this audit history there. So data reproducibility. Why would you want to be able to reproduce data? There's a wide variety of reasons. One of them might be around machine learning. So machine learning with the Azure ML SDK's Azure Machine Learning Service, you're going to be tracking your machine learning models that you've deployed, and you're going to be tracking something that's called ML model drift and the accuracy, and seeing how the accuracy is changing over time because your data underneath the hood is changing. And so oftentimes, machine learning models, they were trained at a point in time, and they had a certain accuracy, and this accuracy can change over time. So then data scientists, when they want to go back and retrain their models, when they want to improve the accuracy of these, they want to have a baseline that they can go back and reference and reproduce exactly what they had before. So data reproducibility comes in handy. Maybe it's about debugging. Debugging comes up often through this process, and we'll show you in a demo an example of that. Okay, and then rollbacks. Time travel makes it really easy to do immediate rollbacks. Think if some bad data creeps in, a lot of times I've seen it so many times in various teams or organizations that I've worked in. Oh man, we have to reprocess the data for last year. We have to reprocess the whole thing. Here with time travel, you can write a statement that says, insert into my table by selecting from that same table as of a previous timestamp. And in this case, we put a where clause for just one user ID. Maybe only one user ID had some corrupt data come in, but maybe you need to roll back the entire table. You remove that where clause. With this simple statement, you've done a rollback. So you could roll back to a particular time, to yesterday's data, whatever it might be. Now imagine also, with these extra commands you can put wheres, you can put joins, you can put all kinds of complex kind of details into this query, and roll back in more complicated ways. You can fix incorrect updates as well with these merge commands. So you can say merge into your table, some target table, using some new update table or whatever it might be. And you can do it from a previous version. You check for a join condition, this on statement, check for this match. And when it's matched, you can take some action, whether it's updating the set, inserting into the set, deleting the set. Or you can also say, when not matched, take a similar operation. So these efficient upserts and merge statements can come into a lot of handy. All right, so let's go into a hands-on demo. I want to show you this in action. Just open my laptop and switch the screen over. Okay. All right, so what we're going to do is we're going to use time travel to reduce carbon emissions and save the world. All right, super exciting, super good. So I'm not a climate change expert or climate scientist or even an economist or any of these things, but I was reading recently one of my friends who lives in Europe, he was telling me about these regulations and the system that I found really interesting, and I thought it was awesome. There's this thing called the European Union Emissions Trading System. Has anyone heard of it before? I saw a nod, maybe. I met a friend from Europe. Have you heard of it before, the European Union Emissions Trading System? Not so much? Okay. So. All right, no problem, yeah. So I didn't know about it either. This has been going on for a while, but so I read about it recently. This is a what they call a cap and trade system. And the principle is that they set a cap on the amount of emissions that companies are allowed to emit each year. And this cap is scheduled to decline year over year. And so it helps companies work to reduce their emissions each year. But what they do is they introduce this kind of trading system. They set these allowances or give the companies credits, and those decline each year. But they allow these companies to trade. Let's see, where's the highlight? They allow these companies to trade these allowances on a trading system, of course, by buying and selling these allowances. So not only does this incentivize the companies to reduce their emissions because of fines and regulation, these things, but they can reduce their emissions, if they can reduce their emissions lower than the regulation, lower than the schedule, then they can make even more money by selling those allowances to other companies and go even further. So I found this a fascinating idea. Seems like kind of motivating. Seems like a good concept. And of course, with a system like this, there's going to be a lot of monitoring, reporting, verification, auditing. Companies have to report each year to some central authority to review and make sure that people are being fair and treating this in an accurate way. And so what we're going to do is we're going to do a simulation of this. Let me start up my simulator here. Make sure I'm connected. Yeah. All right, I'm starting up the simulator. All right, so what we're going to do is we're going to do a little role play. This data set isn't real for this data, but we're going to use it as is. So I'm going to take this IoT data set. This is built right into the DBFS, the Databricks file system. You have this data set in every Databricks workspace that you create. You can reference with the same path. And so it's just this IoT data set to use for demos. And there's a lot of information in here. You can see one that's going to be key for us here is the CO2 level that's being tracked and reported by these sensors all around the world. So we're going to take that data set. Let me just run each command as we go. We're going to take that data set, and this data, these IoT sensors, this data is flowing into event hubs. So same as like Apache Kafka, if people are familiar with Kafka, event hubs is just a real-time like messaging bus, pub-sub model. Think of it as just a giant message buffer in memory. And so we define a connection string to that event hubs, and we say spark.readstream. Execute each of these. Spark.readstream format event hubs using the configuration parameters that we specified above. And then we say take that device raw. We're just going to extract the body and write it to using format delta and checkpointing. In an append mode, we're going to write it to this bronze path that we specified. I can't remember if I defined it there or in my setup notebook. And so we're going to be streaming this data in real time. I have this throttled down to just like a record a second or something dumb, but you could imagine, of course, the scale at which you can go. And so let's inspect this data, see how it looks as it's flowing through. All right, so we have these arrays of strings. Maybe we're not going to get much value or make much sense out of it yet. But we're going to typecast this. We're going to add some schema, add some column names, and then we are going to write this down after we've cleaned it to what we've called the silver path, or our cleaned path at this point. So let's visualize this clean data as it's flowing through. Okay, so now it makes some sense here. This is all flowing in real time at some incredibly slow rate that I've throttled it to. And then we can start doing some aggregations. So let's calculate the CO2 levels for each device type. I'm saying some CO2 level as itself, and I'm grouping by device type and timestamp. So then we're going to plot that on the screen, and we'll see it processing in real time here. All right, so we're going to see this stream continuously update. So I just want you to be familiar here because I'm going to show you something bad that's going to happen to this data set. So I just want to see it updated a couple times. Yeah, so it's updating here. We've got again, this is the sum of the CO2 level grouped by the device type and the timestamp. So this is flowing through. And what I'm going to do is simulate a failure. Let's break all the things. Here we go. Let me just run my disaster simulation notebook. And so there's some peaks that are already here, but watch this because some of the past data is going to get some peaks in the stream as it's flowing through. So these peaks, these orange peaks, these are okay, these are coming in, but in just a second you're going to see an exaggeration of some old data that has some pretty high peaks. Maybe you can make sure this ran. Oh, it's getting the execution contents. All right, it will run here in just a sec. All right, so watch, let's see the old data spike up. So imagine this scenario. You are streaming data from these sensors in real time, you're working with it, and then all of a sudden that happens. I hope you caught it on the screen. Like we had some orange peaks that were there, but then even some older peaks got even higher. Some older data that was at normal levels went much higher. So what could be happening at this point in time? I'll just pause the streams and we'll talk about it. What could be going on wrong? Like, is this late arriving data? Very plausible. The data could come in late and be added into the system. Totally understandable. Is this duplicate data? Is it incorrect data? You know, maybe in this scenario, in this role play that we're doing, maybe we had a snapshot of the data that we reported to the central authority for this European Union emissions trading system. We reported on this data, and it said this month we consumed, this much carbon emissions, and then next month we're reporting like month-over-month percent changes, something like that, and then all of a sudden what we reported last month, like let's say we're in November now, so let's say we reported October levels, and then November we finish, we report November, and then we do a month-over-month comparison. And then all of a sudden, October wasn't what it was when we reported it. So it's like, hey, how'd this happen? And this has happened to me before in real life. Maybe some of you as well. Maybe a nod. Yeah. So let's look at it. So here's what we have right now. Let me run this. So here's what we have right now. There's some peaks in this data. Let's maybe even look at one of these records. Let's say this timestamp that ends with 4334. 4334. Let's look at that individual timestamp and see what's going on here. Looks like I have 2 records, and they're from the same device ID at the same timestamp, so maybe that's okay, but maybe a little suspicious. Let's look over here a little bit more. It looks like the same CO2 level was reported twice at the same exact timestamp from the same device. What could it be? Maybe I'd notice here, like, oh, the device name is different. So let's say, let's start debugging this. Let's say describe history on the table. And we start looking through, we're trying to understand what might have happened. Maybe we're not too sure yet. But let's at least reproduce the data at how it was when we reported to the emissions trading system to make sure we're not crazy. Make sure that this data really was what we said it was previously. So I'm going to take an older timestamp. I'm going to paste it in here. Oh, get rid of this space out of here. And so I'm going to run the data to see what it looked like previously. Before, I mean, this is what it looks like right now. But previously, it used to look like this. There were a couple of spikes here, but it wasn't as exaggerated, and it wasn't as far-reaching. So let's even write a query that shows us the unique difference between these two versions. So I'm going to say select from the table, and then do an outer join. I'm basically just doing kind of like an anti-join or something to give me the distinct differences. Let me replace the timestamp here. Oops. I did a copy somewhere weird. I get my timestamp. Timestamp as of. Okay, let's run this. And what we're going to see, because I'm comparing like different versions of time, so what I'm going to see is that because some duplicate data was added as late arriving data, we're going to see those as unique records to the new version, and then we're going to see what looks like normal values for the rest of the time after the timestamp. I know that concept might be a little confusing. We're doing time travel, right? This is quantum stuff here. Okay, so this query is taking just a second to run, but I'll show you a snapshot of what it looks like real quick in my static notebook, so you get the idea, and we can move on. It's going to look something like this, and you'll see on the left-hand side, these orange lines. That's the actual duplicate data that came into the system. What's after that is just new data that's there after the timestamp at which I'm querying the comparison. And so maybe it's finished by now. Maybe not. And so what we're going to do is do a merge into our data using the difference, because I defined this as a temporary view to make it easy for my queries later. I defined it as a temp view. And I'm saying merge into my clean table using the diff, check if the device ID and the device name, if the device ID matches and the device name does not match. That's what I saw earlier, right, when we inspected that one record. And so I can do that merge after the other command runs. And then we'll see the data clean up from there. So imagine what you have at your fingertips at this time. You're able to go back in time, reproduce the data. You were able to audit this data and try to look through and understand what it was that happened, what it was that might have gone wrong. Then you were able to come through and correct this data and get it back to the right context. And after you ran that, after we run the update, then we select it again, and we'll see that this data has been cleaned up. There's some of those spikes that we talked about, some of those were natural, and so that data has been cleaned up. So this is just a little hands-on walkthrough, help you see how you can use time travel in real life. This is maybe more of a debugging kind of sense, but hopefully you get some of those ideas. So let's do a quick recap here. Let's switch back over. A question in the room, yeah? Yeah. So your question, and I'll repeat it because we don't have you on the mic. The question was, is there a way that I could indicate that the device name was not an important part of the data to make sure that it didn't duplicate or write another record, right? Because in that context, probably what happened, just to theorize, and it could have been something totally different, but maybe the devices reset, or they reset the firmware or something, and this name changed, and then it still had the data around it in its buffer or something like that. and it sent it up to the endpoint, the upload endpoint, and the endpoint said, oh yeah, this looks like a unique row because there's one thing that's different about it. So this is a very good point. Thank you for bringing it up. One of the things that you now have the ability to do is, instead of always doing append in your data, streaming it in, appending it, always adding it, no brainer. Now you can write a statement. You can do these all as like merges instead of appends. And so I wish I had it on the screen. I did it in the hands-on lab on Wednesday. But instead of writing these appends, now you can say for every record that you push in, merge into your table, and then on the match, you can specify these are the important things to look for to compare uniqueness. And if it has the same device ID and the same timestamp, and you know it's only supposed to report once per timestamp, one unique, like really fine-grained timestamp, something like that, then you can say insert it if it's unique on that. Otherwise, delete it or ignore it, or maybe you want to quarantine it or something else. Yeah. Yeah, that would be in the intake pipeline, yep. And so you can write those intake pipelines instead of just normal appends. You could write them as merge statements, each one of those as a merge statement, so that it can check the condition and then write it in. That's another way to also increase the reliability of your pipelines and avoid duplicate data from being pumped. Very good point. Thanks for bringing that up. So yeah, so Delta Lake, time travel, these are really exciting things. Hopefully you got a sense for that. I'll show you a really quick view of the roadmap, and we'll open up for questions as well. Really exciting things we've been working really hard on. We released some new things just this year. Our VNet injection, if some of you, I know most hands said they were using Azure Databricks before, so VNet injection, we went GA about a month ago, I think. Pools, also just a few weeks ago. Pools is a really powerful feature where average cluster startup times right now, maybe 5-7 minutes-ish to start your clusters. But now with pools, what you can do is specify a pool of VMs that are hot and ready to go and that you can share and reuse between clusters. And cluster startup times will go sub 1 minute for you there with pools. So we see a lot of people doing this for reuse and share between jobs, and they have a lot of jobs that they start up together or in fast increments. Of course, Delta Lake went GA in February, announced as open source in April, and now just a few weeks ago, Delta Lake was also adopted into the Linux Foundation. Really exciting, full in on open source there. MLflow, hopefully you guys know about, and also the AML and MLflow integrations that we've been working on, making sure that you can register Azure Machine Learning as a tracking server as well with MLflow, and so that all the APIs that you call with MLflow will, under the hood, be calling Azure Machine Learning so that you can use these two seamlessly together. I won't read and go through everything that's on the list here, but there's also a lot of things that we are working on for the future. Of course, always a continuous investment, security, reliability, and scalability. We want to make sure that this product continues to be the market leader for you and continues to be the best offering of Apache Spark that we have on Azure. So I'll leave you with these helpful links to learn more. And let's open the mic for questions. So if you could come up to one of these mics, ask me some questions. And we have just a few minutes for those. And afterwards, I'll stick around. Maybe we'll even move outside. I think the next presenter wants to come in and set up too, so we'll go from there. Yes?
Currently, it's not possible to use Databricks and Azure Lighthouse together. Yeah. Is that also on the roadmap to be solved?
Yes, definitely. I don't know if I listed it up there, but it's something we're in active discussions on. I don't have any concrete timelines that I could promise you, but it's definitely a hot topic we're discussing. We want to get that support going.
Okay.
Yep.
Thank you.
Mm-hmm. Yeah.
What is the runtime cost of using Delta Lake?
Runtime cost, yeah. So there's no cost for having it in the service. There isn't exactly like a runtime cost, but there's storage cost implications. So you'll have storage cost where, like for storing more data, and you can choose how much like history you want to save for that time travel nature. Does that help?
So okay, yeah, it helps. What I was thinking is if I alter a table, right, before Delta Lake, I have to persist, the new data. Yeah. Now I have to persist the new data and the change logs.
Yep.
So does that?
Yes, the transaction log also will grow with each. So you have some storage implication for the transaction log and some storage implication for the version files that you want to keep. So you can choose how long to keep that around with that vacuum command that we mentioned. By default, it's configured at like 7 days. You can choose to store no history, which maybe wouldn't make sense, or you could choose to store much further history, or you could choose to store hours.
Thanks.
Yep, thank you very much. Question, yeah?
Yeah, I have a question about the secret. Programmatically, I had trouble creating a cluster with just credential, username, and password. You have somehow create the key.
Yes.
Are there plans to add that?
Definitely, great question. And so what you're referencing is what we call in the deployment in this automation, not possible to achieve full automation because you have to go to the UI and generate this PAT token, right? This personal access token. That was in the roadmap slide, and that's something that should be coming out hopefully end of year. In preview, we'll have AAD pass-through authentication. And so that way you wouldn't have a need for generating a PAT token, and you can automate that operationalization of workspace creation, a cluster creation, et cetera. So a very important ask, thanks. So hopefully everyone enjoyed the session. I'll stick around. We can go outside and huddle and chat some more. Appreciate your time. Thank you.